when looking at a problem like that for the first time, and maybe on a placement test for a college or an SAT question or something, when the question is looked like this, you have the question and they write it like this, where they split the denominators up and they put question marks here. What do you think goes above the x plus 3? Whoops, I didn't want that. I wanted an eraser. Okay. I heard 2x plus 16. Okay. Does anybody else have a suggestion? Okay. Let's see. Or this one. Well, let me see. Some people will say that 2x goes here and 16 goes here. Okay, that's fake math. Okay, that does not work that way. Other people will say, you know, there's this thing called common denominators. I bet there's something called common numerators. And they would do this, and they'd put the same thing on both of them. And I said, that must be it. Okay, that's fake math also. All right, none of those is right. Yes, ma'am? 2 and then s plus 8. Okay, so she thinks 2 here and x plus 8 there. Unfortunately, that's not right either. Okay, that's fake math as well. All right, so we need to learn how to do the real thing today. None of those is right. What goes there is some mystery thing A and some mystery thing B that we have to figure out. All right, so what you're going to do, this is called partial fractions because you're going to take something and split it into 2 parts. That's why it's called partial. What we need to do is now look at this. Okay, what's the rule for adding fractions? You must have a common denominator. Do they currently have a common denominator? No. What does the first partial fraction need? It needs an x minus 2. And if I put it on the bottom, I got to put it on the top. All right, what does the second part of the fraction, or the second partial fraction, need? It needs x minus 3, or x plus 3, excuse me. Okay. We now need to distribute capital A to both of those and distribute capital B to both of those. So what we've got now is capital A distributed to x minus 2 in A over, and I don't need to FOIL because that's not what we're focusing on today, the denominator that has now both x plus 3 and x minus 2. And then capital B distributed to x and then 3b, and it is also over the common denominator x plus 3 and x minus 2. Okay, I'm going to zoom out so that I can look at the other side. And what I had on the other side was 2x plus 16 over x plus 3 and x minus 2. So what have I achieved now? What's the same all the way across the whole problem? The denominator. It's common all the way across. From the left side to both parts of the fraction on the right side, everything is common all the way across. When you have achieved that, when you have common denominators all the way across, you can get rid of all of them. Boom, gone. And all you have to work on to solve is the top. It simplifies the problem for you immensely. Okay, now, please put a circle around every part that has an x in it. Okay, so how many did you circle? 3, all right, there's an x, there's an x, there's an x. Okay, those are called like terms. And we're going to separate them out and make a separate equation. So those 3 things. The equal sign goes here, the 2x goes on this side, the ax and bx go on the other. where we only pull out, this is called extraction, you only pull out what the ones that share the x. All right, now put a square or something around what's left. So a 16, a minus 2a, and a 3b. Those we're going to extract into another equation, negative 2a and 3b. And we are going to solve using the methods from this week. Okay, we're going to use substitution or elimination or something to solve. Okay, all right, on the yellow equation, what do they all have in common? An x, so we're going to factor that out of the whole problem. We're actually going to use division, divide x, and you'll be left with 2 equals a plus b. So let's take the yellow equation and the green equation and put them together into a system. So 2 equals a plus b, and 16 equals negative 2a plus 3b. And you may solve that now in any method you like. Okay, what's your favorite method to solve a problem? You could set up a matrix. You could do substitution if you want to get a variable alone. If you like elimination, you could use elimination. Does anybody have a favorite? You could graph if you wanted, but you want to do substitution? Okay, well, if you substitute, you have to pick a variable to get alone. You pick a, and you want to get that a alone right here. So then what would a alone be? 2 minus b. And what do you want to do with the 2 minus b? Plug it into the opposite a, so we have 16 equals negative 2 parentheses 2 minus b plus 3b. Someone else could have done elimination, maybe by multiplying. That would have worked just fine. Okay, either of those methods. I like elimination, that's my favorite, but whatever you like. All right, are we ready to solve that, Destiny? What would you move over? She'd combine the like terms and make them be 5b, and what else would you do? Add 4, so 5b equals 20, so b equals 4. And if b is 4, then what is the a that you said was by itself up here? Okay. So b is 4, and a is negative 2. So what's the purpose? What does that mean? That means at the beginning, when we separated into x plus 3 on the bottom and x minus 2 on the bottom, we had 2 question marks on the top. We now know that the question mark is 4 here and negative 2 there. And that is called partial fractions. It's not hard. You just have to be kind of organized and not messy. So we're going to do 3 more of those before the bell rings, just for practice. Okay, all right, stop me if you have a question. Here's the next one we're going to do. All right, 5 over x cubed plus 3x minus 4. Now partial I said cubed and I wrote squared, sorry. X should be a square. Okay, partial fractions only works when it's in factored form. What kind of factoring does this need? It's got 3 terms, so star factoring. Okay, we're not going to do the star factoring right now. We're going to pretend like we did. Here's the star factor, x plus 4, x minus 1. Can you trust me that that's what it works out to be? But on your homework, you're going to have to do it yourself. Okay, this only works when the bottom is in factored form. So if you have 3 terms, you have to star factor. If you have 2 terms, you have to GCF factor. If you have 4 terms, you have to split factor. It has to be factored. So this is going to be split up into 1 partial fraction with x plus 4 and 1 partial fraction with x minus 1. And since we don't know what's going to go on the top yet, what should we call it? Just like last time. A and B, exactly, all right? So you split up the fraction into 2 parts. Okay, now these 2 parts each need a common denominator to match the other. And so the first one is going to need the x minus 1, and the second one is going to need the x plus 4. So we'll do some distributing of my capital A and my capital B. So I will now have capital AX minus 1A over the common denominator, x plus 4x minus 1, plus, distribute the b, so capital BX plus 4b, also over the common denominator, x plus 4x minus 1. And then I'm going to zoom back out so I can see the other side. And the other side was 5 over the common denominator, x plus 4x minus 1. And I have now achieved common denominators across the entire problem. So what do I get to do when I've achieved common denominators? Cross all the denominators out and only work with the top. So 5 equals AX minus 1A plus BX plus 4B. Then I had you circle everything that has an X in it. All right, well, everything that has an X in it, AX and BX, so those are going to come over here together, AX and BX. But on the other side of the equal sign, what happened? I didn't have anything to circle, did I? So what do we do to hold that spot? Okay, 0, but put an X there, because that means there were 0 X's. There was no X's for me to do. And everything else, I'll put like a green box around, and they'll become the other equation. So that'll be 5 equals negative 1A plus 4B. So with the yellow one, you can drop all the X's. Divide by X, divide by X, divide by X. So I now have 0 equals A plus B, or 1A plus 1B if you want to put the 1's there. Now you have a system. And it is set up beautifully for what kind of method? Yeah, elimination is set up perfectly because you've got a negative 1A and you have a positive 1A. So let's eliminate. Cancel them out. That will give me 5 equals 5B. So B must be equal to 1. And if B is equal to 1, we can go back and plug that back into the other equation. And what will A turn out to be equal to? Negative 1. So what does that mean? It means my original problem that was split up into x plus 4 for one of the fractions and x minus 1 for the other fraction has a negative 1 on top followed by a positive 1 on top. And that is called, again, partial fractions. Okay. All right, let's try another one. See how many we can squeeze there. Okay. Let's try 2x over x squared minus 5x. Okay, I said this only works when the denominator is in what form? Factored form. Is this in factored form? No, x squared minus 5x is not factored form. So, what kind of factoring do I do to a two-term thing? Take out the GCF of x. So it'll be 2x over x minus 5. That's the factors. So I split it up into a plain x and an x minus 5. And I don't know yet what's going to go on the top of either of them. So it's A and B. So I separate it. Okay, I'm going to zoom in. Now I need common denominators. So what does the first partial fraction need? Not negative 5. It needs x minus 5. You can't just subtract something. You've got to do it by multiplication. And what does the second partial fraction need? Just x. So I only have to distribute my a. So I end up with ax minus 5a over the common denominator, x minus 5. And I end up with bx, plus bx over x and x minus 5. I'm going to zoom back out. So the other side of the equal sign will be 2x and x minus 5. Which means now I have common denominators across the whole problem. So I can drop out the common denominator, and I have 2x, I've got 2x equals to ax minus 5a plus bx. So now I would circle everything that has an x. 2x, ax, bx, which means 2x equals ax plus bx. The only thing that's left is the negative 5a. So what was going to be on the other side of its equal sign? 0. I can drop the x's. So I have 2 equals a plus b. So maybe I want to put those two together. And then you ask yourself, well, what's the best method to solve the green equation and the yellow equation at the same time? Okay, I would say get a by itself and then substitute. Okay, if you get a by itself, what do you have to do to both sides? Divide by negative 5. So that's going to give me a equals 0. And if a equals 0, then b is equal to 2. So what does that mean? Well, back in my original equation, I'm going to have a 0 in the a position and a 2 in the b position. Yeah. Yep, so that's how I'm going to read the answers. Okay? Just one final, we're not going to finish this one, I just want to show it to you. Okay, what if you have 3 over x squared minus 4? Okay, I said the denominator, it only works when the denominator's in what form? Okay, well, what are the factors for this one? X plus 2, x minus 2, which means then when you split it up into partial fractions, one of them will have an x plus 2, one of them will have a minus, and then you'll have an a and a b. And then you get common denominators. Okay, I'll zoom in. I'll just go till the bell rings, and then if we don't finish, that's fine. This needs the x minus 2. This needs the x plus 2. We distribute. All right, I'll just keep going just until the bell rings. So ax minus 2a and bx plus 2b. All right, have a great off-campus lunch. Be safe.